These are the solutions for the review for final test questions 52 through 63. So 52 through 55 ask us to know about parallel lines and perpendicular lines. And when we're dealing with this, we need to deal with the slope. So we need to find the slope of the line that's given to us here. So to find the slope, we need to put it in slope-intercept form. So the first thing to do is subtract that 2x from both sides. So when I take away the 2x, I still have that negative 7y, and it equals negative 2x plus 3. Well, then from that point, I go ahead and divide by the negative 7. And remember to divide each of the terms by negative 7. And so when you do that, you're left with a y equals positive 2/7 x minus 3/7. So notice it's a positive because the two negatives cancel. Well, here they're asking us to find the perpendicular slope. So here the slope of our line is 2/7. Well, we want the perpendicular slope. So there's my symbol for perpendicular, upside down t, and it's going to be the opposite sign, so it's going to be negative, and the reciprocal. So the reciprocal of 2/7 is 7/2. So the perpendicular slope is negative 7/2. So make sure you take opposite and reciprocal. Same sort of thing here. You got to find the slope first, so we need to move this 2x over to the other side. So I'll add it to both sides. So now I've got 5y equals 2x plus 6. So the next step is to divide by the coefficient of y, which is 5. And remember, you're dividing each of the terms by 5. So now I have y equals 2/5 x plus 6/5. So again, the whole idea is to look for the slope. Well, the slope of our line is 2/5. This is our slope. And now we're looking for the parallel slope. So parallel slope, here's my symbol for parallel, two lines going in the same direction. M stands for slope, is exactly the same. So parallel lines have the same slope. So you don't change the slope at all, you just leave it the same. All right, another perpendicular one again, so the idea is to move the 2x over. So notice whenever you move a term over, you're doing an opposite operation. So if it's positive on one side, it's going to be negative on the other side. So that might save you some time. So here we're going to divide by the 3, the coefficient of the y term. And now I have y equals negative 2/3 x plus 2. Got the 2 by 6 over 3. Well, here the slope of the line is given to us as negative 2/3. But we don't want that slope. We want the perpendicular slope. So the perpendicular slope is going to be the opposite sign, so positive, and then the reciprocal, 3/2. So that is our perpendicular slope. Parallel slope, again, move the 3x over. So let's try doing that operation like I talked about before. If you move something over, you're doing an opposite sign. So it becomes a negative 3x when you move it to the other side of the equal sign. Still a positive 12, though. And so when you do the division, you divide each of the terms by 4. And so we're left with y equals negative 3/4 x plus 3. So again, the slope of this line is equal to negative 3/4. Well, we want the parallel slope. Parallel slopes are exactly the same. So it's just a negative 3/4. Well, the next set of problems asks us to solve a system. So this is a great one for substitution. So notice that whenever you have x or y by itself, I use substitution. It goes a little faster. So negative 3 needs to be multiplied by this sum, negative 2y minus 4. And then plus 4y equals negative 18. So I go ahead and do some distributive property here, multiply the negative 3 over that sum. I call that a sum because they're the same sign, so they end up adding. And it becomes a positive 6y and a positive 12, and then plus the 4y equals negative 18. So when you go ahead and solve from here, you end up doing some opposite operations and combining of like terms. So I'll go ahead and combine the 6y and this positive 4y, and I'm going to take away the 12 from both sides. So now I've got 10y equals, and this makes negative 30. I had to add them because they're the same sign. And so from that point, I divide by that 10, and you'll have your answer. So divide both sides by 10, so y is negative 3. So negative 3 is the y value. Put that in place of this y here to solve for x. So x equals negative 2 times negative 3, and then a minus 4. So that makes 6 minus 4 makes 2. So x is 2 when y is negative 3. And that's an ordered pair, and that's where the two lines end up crossing. Well, this next one's a great one for the elimination method, because notice how the x's, y's, and constants are all lined up. So I'm going to multiply this one by 3 and this one by 2. They're already opposite in sign, the x terms are, so I could just multiply by the other's coefficient. And here's what we get. We get a 6x, negative 6x, a positive 9y, equals negative 45. Then over on the other one, the bottom one, we get a positive 6x, a positive 4y, and this all equals negative, because the negative times the positive, and that makes it 46. So when you add this stuff together, the x's end up canceling. We've got 13y equals, and this makes a 91, and it's negative at that. And so when I go ahead and do the division, divide by y, or divide by 13. I solve for y. Let's fix that real quick. Divide by the 13. I end up with a y equals, and that makes a negative 7. So 13 goes into 91 7 times. And so I take that 7, substitute it back in for one of these y's. I'll pick this bottom one here. So now I've got 3x plus 2 times that negative 7 makes the negative 14. Equals negative 23. So we end up having to do another opposite operation to solve for x. So now we have 3x equals, and I have to add 14 to both sides. And so when I add the 14, I end up with a negative 9. So when I do the division, x is negative 3. So negative 3 comma negative 7 is where the two lines end up crossing. Well, looking at our next one, it's a great substitution problem again, because you've got an expression with y by itself. So now I've got 2x minus, and then put the parentheses around that 2x minus 4, because that's an expression, and I need to take the opposite of each of those terms, because the minus sign in front of the y. So it becomes a, bring down that 2x, minus 2x, positive 4, minus a 4 equals 0. Well, notice that the x terms cancel. When the x terms cancel, and here the constants cancel as well, and we get two numbers that equal, that means we had the same line. And if we have the same line, the solutions are where the lines cross. In this case, since they're the same line, we have an infinitely many solutions is our answer that we'll end up using. Alright, on this next one, another good substitution problem. So I'll substitute that expression in for y. So now I have negative 6 plus 2x minus 36 equals 2x. Well, when we go ahead and solve this one, we end up subtracting that 2x, and we get a similar instance here, because when we combine these terms, this time we get negative 42 equals 0. Well, when you get all the x's to cancel, last time we had the two numbers equaling. Here they don't equal. And since they don't equal, that means our lines are parallel. Lines are parallel. And if they're parallel, they're not going to end up crossing. So if they don't cross, we don't have a solution. So here there are no solutions. And so that would be our answer in this case. Well, here's some problems that involve writing systems to solve. So it talks about Ed has $44 to buy 7 pairs of socks. And athletic socks cost $5 per pair. Dress socks cost $8 per pair. So let's write a quantity value problem. So we'll start with this. We'll start with athletic socks, A, plus dress socks, D, and he's going to buy 7 pairs altogether. That's our quantity equation. Now, he's going to buy $5 socks, or the cost of athletic socks. So $5 times the amount of athletic socks he buys. And then dress socks cost $8, so $8 times the cost of the dress socks, and he's spending $44. So what they want is how many pairs of each can he buy. So let's go ahead and solve for one of the unknowns. So let's go ahead and multiply this by negative 5, which just seems easier than multiplying by negative 8. So I go ahead and do that. I got negative 5a minus 5d equals negative 35. So we go ahead and do the subtraction. I got 3d equals, do the subtraction here, I end up with 9. And I do the division, I end up with 3. So dress socks, there's going to be 3 of them. How many athletic socks? Well, just subtract that from the total, or substitute back in. A plus D, but in place of D, put the 3, equals 7. So again, you're just subtracting it from the total to come up with your athletic socks that he purchased, which is 4. Next problem is another quantity value problem. We got dimes and quarters contains $3.70. There are 19 coins. So we got number of dimes plus the number of quarters equals 19 coins in all. Well, the value of a dime is 10 cents. The value of a quarter is 25 cents. So if we multiply those values by the number of coins of each of the types, that will equal the amount of money we have, $3.70. But notice I'm not writing 3.70. I wrote 370 because I'm in cents here. 10 cents times the number of dimes, 25 cents times the number of quarters is going to equal cents. So they want to know how many of each type of coin. Well, let's go ahead and multiply this top equation by negative 10, each of those numbers. So I end up with a negative 10D minus 10Q, all equals negative 190. So I do some subtraction. 15Q equals, and this ends up equaling 180 when I do the subtraction. So when I divide by 15 on all sides, I end up with the number of quarters equaling 12. So 12 quarters. If I subtract that from the total, so number of dimes is going to equal the 19 minus 12. Number of quarters subtracted from the total gives me 7 dimes altogether. So 7 dimes, 12 quarters. Look at our next one. It's the same type of problem, but this time we have nickels and quarters. So N plus Q equals, looks like 86 coins. $18.70 is what we have in those coins. So 5N plus 25Q all equals 1,870 cents. So let's go ahead and multiply by negative 5, that top equation there by negative 5, each of those numbers there. So now we've got negative 5N minus 5Q equals negative 430. And so when I go ahead and add this stuff together, I end up having a 20Q equals, and this makes a 0, carry a 4, and this makes 4 and a 1. And so when I do that division, think of it this way. Think of crossing off these zeros, and how many times does 2 go into 144? Well, Q is going to be 72. So 72 quarters. Well, how many nickels? We'll just subtract 72 from the total. So just 86 minus 72. And that gives me 14. So 14 nickels is our answer. Well, this is a similar problem. It's a ticket problem, though. So it goes this way. We've got the admissions of adults plus children equals the total people who showed up, 830 people. And then the adult ticket looks like it cost $4 for the adult tickets, $3 for the children's tickets, and we got $2,730. Now notice this is in dollars this time. Well, they want to know how many adults and how many children. So let's go ahead and multiply by one of these numbers. Top equation will multiply, how about by negative 3? And so each of those equations, and so we got negative 3a minus 3c equals, that makes 0, 9, and 24, and that's negative. And so when you add this stuff up, we'll end up with just 1a equaling, and then we go ahead and do that subtraction, and we get 240. And that would be the number of adults. Well, if we just subtract that from 830, that'll give us the number of children who attended. And so we do that subtraction, we end up with 590. So 590 children, 240 adults. Well, those are problems up through 63. Check other parts for other problems.